All right, this is APBC Calc. We're doing midterm review, and this is for your response 21C, which is non-calculator. So now we're given a different value of k, and we're asked to find an integral or show that it diverges. Well, this is a hint that it might be improper. Like, this is a hint that this could be an improper integral because the only integrals we see that diverge, right, are usually integrals that have some sort of an improper issue, right? Meaning they have an infinite bound or they have a vertical asymptote or something else. Well, if I plug in, right, so I'm integrating from 0 to 2 of 1 over x squared minus 2x plus 1 with respect to x. Well, this is definitely an x minus 1 times an x minus 1. So what I'm looking at is I'm looking at a graph inside this integrand that definitely has a vertical asymptote at 1, right? There is definitely a vertical asymptote at x equals 1, and 1 is between 0 and 2, which when we did the last video, we didn't have to worry about it because there were vertical asymptotes, but they didn't fall in the window we were looking at. So basically what's happening is I'm going to have to split this thing into two integrals, an integral from 0 to a bound that is approaching 1 from the left, right? And then also some bound approaching 1 from the right to 2, right, which is a lot. Okay, so we're going to make this the limit as b approaches 1, right, from the left, right, of the integral from 0 to b of this thing with respect to x, plus the integral, so another limit, the limit as, let's say, a approaches 1 from the right, of a to 2 of 1 over x minus 1 quantity squared dx. So both of these are simple u-subs. So if I kind of cheat and I'm going to, in red over here, I'm going to do a little bit of quick u-sub work. If I just asked you to integrate this, right, this is u equals x minus 1. My du is just my dx. And so this is really integrating a 1 over u squared du, or a u to the negative second du, which I up the power by 1 and divide by the new power. So basically, this is a negative 1 over u. That's what I'm going to get when I integrate. Now this is just like separate work that I do off to the side, right? This is my like quick u sub work, because that way I don't have to integrate this thing twice. It's the exact same integral, right? I just have to know what's going to happen. So right away, I'm going to tell you that looking at this, I know we've got a situation where this thing diverges. And actually, let me add one more line here, and I'll show you why. Hang on, we'll use the tiny eraser because I accidentally erased too much. So here's the reason I'm going to know that this diverges. 1 is still a problem. Like, see how I still have an x minus 1 on the bottom? When I go to plug in, it's going to be a b when I integrate over here. But I still have to try plugging in 1 for b, and 1 is still going to create a problem on the bottom. It's not like this asymptote magically disappeared. I'm still going to have an issue. And we can see that. So if I integrate, right, this is going to end up being the limit as b approaches 1 from the left of what we now know is a negative 1 over this x minus 1 from 0 to b, right, plus the same exact thing. I'm just using a's and I'm approaching from the other side, but it's the same thing, negative 1 x minus 1 from a to 2. Well, here's the problem. I'm going to get that this is the limit as b approaches 1 from the left of negative 1 over b minus 1, minus, and then this is fine, it's a negative 1 over negative 1, we'll deal with it, right, plus this limit as a approaches 1 from the positive, oh, sorry, didn't mean to put that first, should have put that second, but we'll get to it in just a second. So plus negative 1 over 2 minus 1, we'll deal with that as like minus the limit as a approaches 1 from the positive of negative 1 over minus 1. Here's the problem. This is just not existent. Like, this is not a finite value, right? And either is this one, right? Like this one too, not a finite value. So the second you have an infinitely large value when you're evaluating an integral, that's it, you're done, it diverges. Even if your brain's like, oh, this infinite value minus this infinite value, nope, not the way it works. The second you throw in an infinite value, it's a problem. So this thing diverges. And the reason is because either, like, it doesn't matter, pick either one of them, but the limit as b approaches 1 from the left of negative 1 over b minus 1 is not a finite value, right? So like this is not finite, right? This essentially, it doesn't exist. It's an infinite value. It's not going to work. So the second that happens, you're done, and it diverges. And as you get better at these, you can start to see them. Like if it's multiple choice, I could see this pretty early because as soon as I do this U sub, I'll see that 1 is still a problem if I try plugging 1 in, and I can stop there. And free response is a little harder because you do need to be really mindful of this limit notation, and they really will ding you with a point if your limit notation is off, and that's frustrating. But that's it.